All right, so for these examples here, we are going to be finding the growth rate. Okay, so the growth rate is going to be represented by the letter R, and it's basically going to be the same thing we did previously when we were solving for t. Example 1, the population of a country is growing exponentially. In the year 2000, it was 10 million, and in 2005, it was 12 million. What is the growth rate? All right, so this is still a population growth, and the formula for that is n of t equals n sub 0 times e to the power of RT. Okay, once again, just a reminder, it's the same formula as the investment formula for an investment that is compounded continuously, A equals per. All right, it's the same formula. And we're using E because it is compounded continuously. Anyhow, I'm just going to use the basic formula. Okay, N of T is the ending population, so that here is 12 million. That's the N of T. And N sub 0 is the starting population at time 0. And for the time t, let's see. Well, we started at the year 2000. So the year 2000 is when t equals 0. That's when we start. And the year 2005, how many years elapsed from 2000 to 2005? Well, that's 5 years. Right? Because if we started in 2000 and we wound up in 2005, that is a span of 5 years. Okay, so the population's been growing for 5 years. So that the year 2000, that's at t equals 0. And in 2005, that's t equals 5. All right, so basically we're using t equals 5 because the population has been growing for 5 years. All right, anyhow, N of t is 12 million. And I'm just going to write 12m. Okay, you really do not need to write 6 zeros because we're going to end up dividing by n sub 0 anyway. All right, and n sub 0, the population at time 0, that was 10 million. All right, and that is times e to the power of r, which we do not know. All right, they asked the growth rate, so r is what we're looking for. And the t is the time, and we said that was 5 years. All right, so for t, that is going to be 5, all right? The exponent is r times 5, or 5r. Just like last time, this exponent, we want to isolate it, but it's only applied to the e. We want to get rid of 10 million. So I'm going to divide both sides by 10 million. Okay, again, if you want to write the 6 zeros, you can, but it's irrelevant. It's going to cancel. On the right, 10 million over itself is gone. On the left, a million divided by a million cancels. And you can reduce this. You can make it 1.2. Like I always say, I like to leave it as a fraction. All right, so 12 over 10 is going to equal e to the power of r times 5, which is just 5r. Now, just like last time, in order to isolate that exponent, we want to take the log base e. And we already said the log base e, that's the same as natural log. All right, so I'm going to do the natural log on both sides of the equal sign. On the right-hand side, the natural log and the e are canceled. We're left with the exponent of 5r. All right, so we have ln of 12 over 10. And that equals 5r, or 5 times r. The opposite of times 5 is divided by 5. All right, I'm going to do this on the calculator. Okay, ln of 12 tenths, close parentheses, divided by 5, numerator and denominator. Hit equals, we can do 4 decimals, 0.0365, okay? I'm going to round it up, 0.0365. All right, now that is my rate, and remember the units on R and T must match, okay? So let me write that off to the side here. Units of R and T match. All right, so that's a good reminder there. The units of R and T, they have to match. So let's see for a minute now. T went from year 2000 to year 2005. So T, okay, we said T was in years. So that rate, that number that we just got, that rate is per year. Okay, now we want it in terms of a percentage. So percentage, decimal to percent, you move the decimal over 2 places. Okay, and that is going to equal 3.65% per year. And that is your final answer. That's right, 3.65% per year. Example 2, suppose a bacteria culture contains 2,500 bacteria at 1, and at 130 there are 6,000. What is the hourly growth rate? Okay, so once again, we have a population growth. All right, so we're going to use n of t equals n sub 0 times e to the power of RT. And again, you can use a equals pert if you like. All right, n of t is the ending value of the population growth. So at 130, there's 6,000. That's going to be your n of t. N sub 0 is the population at time 0, your starting population. So that was 2,500. All right, E is a number, R is what we're solving for. And T runs from 1 o'clock to 1:30. All right, so from 1 o'clock to 1:30, we know that T is 30 minutes. However, they are asking us for the hourly growth rate, so we might as well make T in hours. Remember, you want the units on R and T to match. Okay, so 30 minutes is the equivalent of a half hour, or 0.5 hours. Okay, so let's use 0.5 hours instead of 30 minutes because we want the hourly growth rate. If we use hours for T, the units on R will be per hour. Okay, and that's what we want. All right, N of T, that's going to be 6,000. N sub 0 is going to be 2,500. And that's times E to the power of R times t, which is 0.5. All right. So, as always, the exponent is only on the e, so we want to get rid of the constant term, the coefficient, times 2,500. The opposite is divided by 2,500. All right, do that to both sides. On the right, it cancels. And we can cancel a couple zeros divided by 100 top and bottom. We're left with 60 over 25. And that equals e to the power of r times 0.5. So it's just going to be 0.5 r. All right, now, since we have a base of e with this exponent, we want to use log base e, which is the natural log, okay? You want to do the same thing to both sides. And natural log and e cancel because this is log base e. So those cancel, and we are just left with the exponent. On the left, we're going to leave that alone for now. So ln of 60 over 25. And that equals 0.5 r. All right, r times 0.5. The opposite is divided by 0.5. On the right, it cancels. We're left with r equals ln of 60 over 25 divided by 1/2, or 0.5. All right, ln of 60 over 25, close parentheses, divided by 0.5. All right, which really is the same thing as times 2. Anyhow, hit equals, and rounding off, 1.751. All right, so that is the rate per hour. Now, how do you convert a decimal to percentage? Well, you need to move the decimal over 2 places. So it's approximately 175.1%, and that is per hour. Okay, they didn't say how many decimal places. Maybe just 175% would be appropriate, but I wrote it as 0.1. All right, no big deal. Example 3, last one. Certain species of fish is introduced into a large lake. Biologists expect the population to double every 4 months for the first few years. What is the annual growth rate? All right, population growth. So we are still using n of t equals n sub 0 e to the power of rt. So let's see. The population doubles every 4 months. So the time span, t, is just 4 months. However, they want the annual growth rate, in other words, in years. So we might as well convert months to years. How many years is 4 months? Well, that is basically just 4 over 12 months. And if you reduce 4 over 12, that's just 1/3. 1/3 months. All right, so that's what we're going to use for t. Now let's see, anything else? We don't have a starting population or a finishing population. So we don't know where it starts, but n sub 0 is just going to be left alone. We're going to leave n sub 0 as n sub 0. But in 4 months, the population doubles. So since it doubles, that means n of t, the ending population, is going to be 2 times n sub 0. All right, so for n of t, we're just going to use 2 n sub 0 because it's going to double. And now we're in business. All right, n of t is going to be 2 n sub 0. That just means whatever you started with at times 0, it's going to be times 2. N sub 0 we don't know, and that is to the power of e. R is 1/3. And t we don't know. So the exponent here, if I can make this a little cleaner, the exponent here is 1/3 t. All right, we're solving for t. No, we're not. We're solving for r. Okay, t is 1/3, and r is the number times t. It's 1/3 times r. All right, 1/3 times r times 1/3 or 1/3 r, same thing. All right, solving for r. This is n sub 0 times e. We want to isolate e with the exponent, so we're going to divide both sides by n sub 0. All right, because this is times n sub 0. The opposite is divided by. Cancels on the right, and it cancels on the left as well. We're left with the 2 equals e to the power of 1/3 r. All right, again, that 1/3 r is your exponent. And as always, in order to get rid of the e and isolate the exponent, we have to do the natural log on both sides. On the right-hand side, natural log and e cancel. And we are left with 1/3 times r. Natural log of 2, we're going to do on the calculator. All right, so times 1/3. How do we get rid of that? Multiply by the reciprocal. So times 1/3 times 3 on both sides. 3 over 3 cancels. We're left with the r. 3 times ln of 2. All right, hit clear. Let me see if I can just do 3 ln of 2. This is 3 times ln of 2. I want to see if it takes it without the times. Yes, it does. Let me see. 2.079. 3 times ln of 2. Yeah, same thing. 2.079. There you go. All right, and we had the units for t. Let me see. 4 months, but when we did 4 over 12, that was 4 over 12 years. All right, little mistake there. 1/3 was in years. All right, so since t was in years, this growth rate r is per year. Now, converting to percentage, 2 units. All right, that's 207.9. I'm just going to make it 208. So that's 208% per year. All right, so that's how fast the population is growing. 208% per year.